Alright, so remember last time we ended with solving the fundamental theorem of calculus, solving a definite integral using the fundamental theorem of calculus by hand. Alright, so today I'm going to go over how to do this on your graphing calculator. And I'm going to show you one method. There is another method, and if you know how to use it, that's fine. But this method works for all graphing calculators. Alright, so no matter what kind you have, this graphing method will work. Alright, so how to solve the definite integral. If you can't find the general antiderivative, the graphing method is always one you can fall back on. Alright, the biggest thing is when you're using this method, and I already have that circled. Alright, we're going to do this graphically. Alright, so the first step is we're going to graph the given function. So that's the one I had circled before. So this is the function we're going to graph, the f lowercase s, what's given to me in my integral. Alright, so that's what we graph. So graph the lowercase f of x in your calculator. Make sure your window is big enough to include these upper and lower values. So if those were something bigger than 10, right, we usually use a standard window. But if those values are bigger than, than 10, or bigger than -10, or smaller than -10, we'll adjust the window to make sure I can graph the function and see the function. Alright, we're going to go to second trace. Once we've graphed it, hit 7 on the list, which is the integral, and then your calculator will ask you to plug in the upper bound, or the lower bound, which is the smaller number, and the upper bound, which is the bigger number, and then it'll actually shade the area in when it solves it. Alright, so I'm going to walk through an example. I'm going to show it to you on the calculator. Alright, so I pulled one from your book. Alright, it's problem number 42 from your textbook. Alright, I'm going to integrate. They're asking you to integrate from e to e squared of 1 over x times the natural log of x. Alright, now this function, if I tried to solve it by hand, is incredibly difficult. Alright, there is a way to do it. We're not going to. We're going to solve it on the calculator. Alright, so I am going to graph this function, and so I'm going to go ahead and go to my graphing calculator. So I've got it up here. So hopefully you have yours out, since this is the graphing method. Alright, so I've got my TI-84 up here, and I'm going to show you. So first thing you do is you graph the original function. So go in here, and I've already got mine typed in. Alright, but make sure you type it in. The biggest thing about this is make sure when you take 1 divide by, you've got this set of parentheses. It's important that you take 1 divide by parentheses, x times the natural log of x, and then you'll have to have parentheses twice because you'll end the natural log, parentheses, and then the big function. You have to make sure you do that. If you don't, then it won't have the right function. What it'll do without that set of parentheses, it'll be 1 over x times the natural log. So first step, those set of parentheses are important. And then I changed my window, and so I'm going to go to window to show you just so that I could see the picture a little better. Alright, so I adjusted my window from a standard window. Remember, standard window is a 10 by 10. And so I made my x minimum -5, my x maximum 15. I left my scales alone. I put my y minimum -1 and my y max 2 because everything kind of happens close to the axes. And then so this is going to allow me to see it a little better. Alright, so I adjusted my window to that. And now graph it. Alright, so graph my function. Alright, so there's a piece of it that's missing that's below the x-axis here, but I don't need that. I just need the piece that we're looking at here. Alright, so I'm going to clear this out so that you can see so down here is what buttons I'm pressing. Alright, so second trace. So go there. If you look at the 7th one down, there's my integral symbol. There's the integration of f of x with respect to x. And so that's what I pick. I picked 7. Alright, then the calculator asks you for your lower limit. My lower limit was e. And when it's just e, it's e to the first. So you type in e to the first. Hit enter. Then it'll ask you for the upper limit, which was e squared. So you type in e to the second. Hit enter. And then the calculator will shade that area in. Alright, so see it shaded it in there? And gave me out the value 0.693144718. And so I'm just going to approximate that, but that would be what the function equals, the definite integral equals. So I'm going to go back to my notes, and I know this integration is approximately 0.69134. I round a few decimal places. Alright, we found it by graphing. Alright, so the picture that we came out, again, there's a little piece down here. Alright, that was my 1 over the natural log of x. Went from e to e squared, and that's that area we found. That area equals that 0.69134. I'm going to do a second example just to show you it one more time. Alright, so my second example, I'm going to integrate 2 to 8 of my function 1 over x squared plus 6x with respect to dx. Alright, so again, I'm going to go back to the calculator. So I'm going to clear this out. Clear. Alright, so it was 1 divided by x squared plus 6x. Alright, I'm going to go back to, I know I need 2 and 8. So I'm going to go back to, maybe I'm going to hit my zoom and I'm going to start with a standard window. Alright, so standard window. Let's see if it gives me the picture that I want. And it's a little off my page. Alright, so I might make my window a little bigger in the Y direction, just to see what's going on there. So, if I graph it, there it is. Alright, so there's a little bit better looking picture. And now I'm going to find it. Second trace, 7. Lower limit 2. Upper limit, so 2 enter, and then upper limit was 8. Alright, and then it'll shade it in. And so it shades in and finds the area. So the area under this curve from 2 to 8 is 180.375. Alright, and so there's my answer. 180.375. Alright, using my calculator. You could find this one by hand, and you could check your answer if you want to. Alright, using the definite integral, the fundamental theorem of calculus to find the area of the curve from integral a to b. And again, we'll be using the calculator as it's just good practice. Alright, so our function g of x from x squared plus 3x plus 100 from negative 3 to 5, use the definite integral graph it, shade in the reason. Alright, so this is the first case. So negative 3 to 5, x squared plus 3x plus 100 with respect to dx. Alright, so there's my integral. Alright, and then we're going to solve it graphically. Alright, so on your calculator, you're going to graph. Now this one you will have to make your window bigger. I know at the very least because 100's there. So if you wanted to, you could start with, you know, negative 10 to 10, because I know my x values land. And then maybe I'd change my y maximum to 200. Alright, double that. And then I leave everything else 10s. Alright, so I'd leave everything 10, negative 10 except for my y maximum. Alright, should be a parabola, so it hits 100. That's why I know I need to go past 100. So my rule of thumb is to double it. And it does look like it's a pretty decent window. I'm just going to graph it here. Alright, so there is my g of x function. And then you're going to hit, you know, your second trace, pick 7. Upper limit, lower limit, so lower limit 3, upper limit 5, and then the calculator should shade it in. Alright. That's what we're asking for. Graph it and shade it. Well, the calculator does the work for you. It graphs it and shades it, and it tells me the integration of this function from negative 3 to 5, that shaded area, came out to be 874.67. Alright, and that was the answer for the area. Alright, the area under my curve is 874.67. Alright, based on my integration. And I know it's the area because the function is positive everywhere it's shaded in. This is exactly what the area is, and the calculator shows me that. Alright, the second case. Alright, my function 4 minus x squared. Alright, so this one is going to be the second case, which means I'm going to have to do a little work in order to determine my area. Alright, so first I'm going to integrate it from 0 to 4. Alright, which I'm going to solve it graphically. I'm actually just going to graph it over here and find what it is. Alright, so if I graph the function, this time I am going to go back to a standard window. Alright, a standard 10 by 10, so when I go to graph this and when you plug it in your calculator, go back to a standard. Alright, so it's a parabola that's opening down. Alright, then you're going to hit your second trace, 0 to 4. That actually hits it at 2. 4 is over here, and if we shade it in, it actually does go off my page. Alright, the calculator shades it in and finds that that comes out to a negative 0.0 negative 5.33 repeating, or negative 16/3 if you prefer. So either one of those would be fine. All right, negative 16/3 or negative 5.33 repeating. All right, it's negative, which means there's more negative area than positive area, right? Remember, this is an accumulation, so I've got a little bit of positive I'm accumulating up here, and a whole lot of negative I'm accumulating down here. And so what that means is it means we have more negative area. All right, I actually know that I've got negative 16/3 more negative area, right? Because when we took the difference, that's what we were left with, right? Area above minus area below. All right, well, how do I figure out what the actual area is if I want to know what the total area is without subtracting it? Well, what we can do is we can split it. I can find my area above and then add to it the absolute value of the area below. I know at 2 is where it switches, right? From 0 to 2 it's positive, and from 2 to 4 it's negative. All right, and so that's what I'm going to do. All right, so how can we find the exact area? Well, I'm going to find my positive area, which is from 0 to 2, and then add to that the negative, or the area below, which goes from 2 to 4, and I'm going to take the absolute value of that. All right, so we're going to integrate from 0 to 2 of my function 4 minus x squared. Add to that, integrating 2 to 4, and I know this one should come out negative. All right, well, we already have the graph of the picture. All right, I might regraph it. So I'm going to come down here and I'm going to regraph it. All right, so, and you might want to hit like regraph on your calculator, so it'll unshade the area. All right, so the first thing I'm going to do is I'm going to find the area from 0 to 2. All right, so that's the first thing I'm going to do. I'm going to go hit second trace on my calculator and just find the area from 0 to 2. So my lower value is 0, my upper value is 2. Well, when you do that, this comes out, this positive area is 5.33 repeating. All right, so 16/3. All right, then I'm going to find the area from 2 to 4, which I know this area from 2 to 4 should come out negative. So I'm integrating from 2 to 4. All right, so that's this part here, 2 to 4. And I know it should come out negative, and it does. When I integrate from 2 to 4, lower value 2, upper value 4, it comes out negative 10.66 repeating. So that'd be negative 10 2/3. All right, take the absolute value of that, so it's 16/3 plus negative 10 2/3. Oops, plus, not minus, because I took the absolute value, which comes out to 16. All right, so 16 is my total area, is 16 units. 16 1/3 was above the x-axis. 10 2/3 was below the x-axis. And when I took the difference, it came out negative 16/3, right? If you take 16/3 minus 10 2/3, it comes out negative 16 1/3, which is what my integration does, all right? It takes this area minus this area to get to my total area. All right, so on your own, looking at the book problems, the connect problems, the extra practice worksheets, practice finding the definite integral. Do it both by hand and on the calculator. You will need to do it both ways, all right? By hand, I will ask you to do it by hand. You need to know how to do it by hand. If you don't show it by hand, you will not get points. All right, and again, using your calculator is also an important skill, and so that'll be something that you'll be asked to do as well. All right, so you need to know how to do both of them. So make sure when you're practicing these, you're practicing both the by hand method and the calculator method, both of them. All right, a lot of times what's good is we'll do it by hand and then check your answer on the calculator. All right, we'll stop there.